Here is a question on general organic chemistry. Read the question carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Effervescence with sodium carbonate, Na2CO3, occurs when an acid is strong enough to liberate CO2 gas from carbonate. The reaction is 2Ha plus Na2CO3 to Na plus H2O plus CO2. For CO2 to be released, the acid must be stronger than carbonic acid, pK-6.35 for first dissociation. Moving on to the next step. A. C6H5CO2H, benzoic acid pK-4.2. This is stronger than carbonic acid, so it will react with Na2CO3 to give CO2 effervescence. B. Benzenesulfonic acid, C6H5SO3H pK-1. This is a strong acid, much stronger than carbonic acid, so it will react with Na2CO3 to give CO2 effervescence. C. C6H5O, phenol pK-10. This is weaker than carbonic acid, pK-6.35. Therefore, phenol cannot displace CO2 from Na2CO3. Phenol does react with NaOH, a strong base, but not with Na2CO3 to give effervescence. D. 2,4,6 trinitrophenol, picric acid pK-0.38. The 3 electron withdrawing nitro groups drastically increase the acidity of the phenolic O, making picric acid stronger than carbonic acid. It will react with Na2CO3 to give CO2 effervescence. Moving on to the next step. Identify which compound does not give effervescence. Only phenol, C6H5O, is too weak an acid, pK-10, to liberate CO2 from Na2CO3. All others are sufficiently acidic. And for the final step. A. Benzoic acid strong enough, gives effervescence. B. Benzenesulfonic acid strong acid, gives effervescence. D. Picric acid highly acidic phenol derivative, gives effervescence. Therefore, the correct answer is C. Therefore, the correct answer is option C.